Dear students, good morning. Today we are going to discuss about the lesson acids and bases. In our daily life, we come across different food substances. Can you name some substances that are sour in taste? Yes, tamarind, grapes, curd, and lemon are sour. They are said to be acidic. Some substances like sodium bicarbonate and soap are bitter in taste. They are said to be basic. Acids and bases are any one of the important classification of chemical compounds, which plays a significant role in every field of science. For example, we used to have vinegar in the kitchen. Acids and bases are biologically, industrially, and environmentally important compounds. For example, among the medicines we use, aspirin is acidic and antacids are basic. Dietary fats are acids and the chemical compounds in DNA are bases. This lesson we are going to discuss about properties and uses of acids and bases, how we can able to neutralize, and the basic indicators. First we move on to acids. Acid is derived from the Latin word acidus, which means sour. Thus, the chemical compounds which have sour taste are generally called as acids. All acids contain one or more replaceable hydrogen atom in their molecules, and when dissolved in water, they release H plus ions. For example, hydrochloric acid HCl, sulphuric acid H2SO4, and nitric acid HNO3 release hydrogen ions H plus when dissolved in water. So the first case, hydrochloric acid when dissolved in water gives hydrogen ion plus chloride ion. HCl and reaction H2O gives H plus Cl minus. The next, sulphuric acid H2SO4 and reaction dissolves in water, H2O gives hydrogen ion to H plus sulfate ion SO4 2 minus. Do you know Swedish chemist Svante Arrhenius proposed a theory on acids. According to him, an acid is a substance which furnishes H plus ions or H3O plus ions in aqueous solution. Thus, acids are defined as the chemical substance which release hydrogen ions when dissolved in water. Acids can be classified into two types: organic acids and inorganic acids, depending on the source. Some acids occur naturally in fruits and vegetables. These are called organic acids. Can you name some examples? Lemon, tamarind, apple, tomato. These are all organic acids. Now we are going to see organic acids and their sources. Name of the acid: citric acid, that is in the source you can say lemon. Lactic acid, sour milk. And oxalic acid is present in tomato. Acetic acid present in vinegar. Malic acid present in apple. And tartaric acid present in tamarind. On the other hand, acids are produced artificially in industries. These acids are called mineral acids or inorganic acids. They are highly corrosive. Examples: hydrochloric acid, sulphuric acid, nitric acid. Next, we move on to properties of acids. There is physical properties. Acids are sour in taste. They are corrosive in nature. Strong acid can spoil substances like human skin, clothes, and paper. Generally, acids exist in liquid state, but few acids exist in solid state. For example, benzoic acid. Then acids are colorless. Colorless means white color we can able to see. Acids change the color of the indicators. Blue litmus turns to red and methyl orange turns pink when treated with acids. So they are soluble in water. Solutions of acids conduct electricity due to ionization in water. Do you know we feel hungry due to corrosive action of hydrochloric acid on the inner lining of the stomach. When the level of the hydrochloric acid goes higher, it causes cancer. Next, we move on to chemical properties. This we are going to see three cases: reaction with metals, reaction with metal carbonates and bicarbonates, and reaction with metal oxides. Metals like zinc, magnesium, aluminum, iron, etc. react with acids like hydrochloric acid, sulphuric acid to form metal salts and releases hydrogen gas. For example, zinc plus hydrochloric acid gives zinc chloride plus hydrogen. The arrow in upward direction indicates it is in the form of gas. The second one, iron plus sulphuric acid gives ferrous sulfate plus hydrogen. Reaction with metal carbonates and bicarbonates. When carbonates and bicarbonates come into contact with dilute acid, carbon dioxide is given out along with water. For example, limestone, that is calcium carbonate, reacts with dilute sulphuric acid to form calcium sulfate, carbon dioxide and water. The third case, reaction with metal oxide. Oxides of various metals reacts with dilute acid to form their metallic salts and water. For example, calcium oxide plus hydrochloric acid gives calcium chloride plus water. Now we move on to uses of acids. Hydrochloric acid present in our stomach helps in digestion of food materials. Vinegar is used to preserve food materials. Benzoic acid is also used to preserve food materials like pickles. Sodium or potassium salts of higher fatty acids are used to make washing and bathing soaps. Do you know which acid is said to be king of chemicals? Yes, sulfuric acid. It is an effective dehydrating agent. It is used in various industries to make detergents, paints, fertilizers, and many more chemicals. The economic status of a country can be determined only by making use of this sulfuric acid. And then hydrochloric acid, nitric acid, and sulfuric acid are important laboratory reagents. Cells of all living organisms contain the fundamental nuclear material called nucleic acid. So the animals have DNA. DNA means deoxyribonucleic acid, whereas plants contain RNA, ribonucleic acid. Copper or brass cooking vessels are coated with a tin metal. They say EM. If it is not coated, the organic acid present in the food particles will react with copper and make the food poisonous. The tin isolates the vessel from the action of acids and prevents food poisoning. Pickles remain in good condition for long time because they contain vinegar, acetic acid or benzoic acid. Next, move on to bases. Bases are chemical substances that are corrosive and bitter in taste. You can see this in case of soap, detergents, paste. In contrast to acids which release hydrogen ion in water, bases release hydroxide ion. Thus the chemical substance that release hydroxide ion, that is OH minus, when dissolved in water are called bases. Sodium hydroxide dissolved in water gives sodium ion Na plus and hydroxide ion OH minus. Similarly, potassium hydroxide and dissolves in water gives potassium ion K plus, hydrogen hydroxide ion OH minus. Some bases are soluble in water. So, water soluble bases are called alkalis. Bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide are highly soluble in water and hence they are called alkalis. Some common bases in some products you can see. There is a base, formula, and the products. Magnesium hydroxide, MgOH twice, milk of magnesia. Sodium hydroxide, NaOH, product you can see as detergents. Detergent means soaps, powder. Ammonium hydroxide, NH4OH, solution for cleaning windows. Calcium hydroxide, CaOH twice, product is lime water. Then potassium hydroxide, KOH, product is soap. Sodium carbonate, Na2CO3 is commercially called as washing soda. Similarly, sodium bicarbonate is commercially called as baking soda. Caustic soda is sodium hydroxide, NaOH, and caustic potash is potassium hydroxide, KOH. Properties of bases. Bases generally exist in solid state but some bases exist in liquid state also. Example, ammonium hydroxide, calcium hydroxide. Bases give soapy touch only in aqueous medium, not in dry nature. Bases are bitter in taste. They are colorless. Bases are corrosive in nature. When comes in contact with the skin frequently, they form painful blisters. Bases also change the color of the indicators. Red litmus paper turns blue when treated with bases. Similarly, they turn methyl orange to yellow, phenolphthalein to pink color. It also conducts electricity in aqueous solution. Now we are going to see chemical properties. Reaction with metals, non-metal, and then ammonium salts. Generally, metals do not react with bases. Metals like aluminum and zinc react with bases like sodium hydroxide, forming aluminates and release hydrogen. Reaction with non-metal. All the bases reacts with non-metallic oxides to form salt and water. For example, sodium hydroxide reacts with carbon dioxide to form sodium carbonate and water. Reaction with ammonium salts. Sodium hydroxide and reacts with ammonium chloride gives sodium chloride plus ammonia plus water. Though acids and bases have some unique properties, there are certain similarities between them. That is, they are corrosive in nature, they undergo ionization in aqueous solution, they conduct electricity in aqueous solution, and then finally they undergo neutralization reaction. Now we are going to see the difference between acids and bases. They produce hydrogen ion, H plus ion in water. They produce hydroxide ion, OH ion minus ion in water. They are sour in taste, they are bitter in taste. Few acids are in solid state, most of the bases are in solid state. Acid turns blue litmus to red, bases turn red litmus to blue. So now, uses of bases. Potassium hydroxide is used to make bathing soaps. Sodium hydroxide is used to make washing soaps. Sodium hydroxide is also used in paper industries, textile industries, and in preparation of medicine. Calcium hydroxide is used for whitewashing. Aluminum hydroxide and magnesium hydroxide are used in antacids to cure acidity problems. And finally, ammonium hydroxide is used to manufacture fertilizers, nylon, plastics, and rubber. Neutralization reaction. It is a chemical reaction in which an acid and a base reacts with each other to form salt and water. Acid plus base gives salt plus water. Then move on to indicators. An indicator or acid-base indicator is a chemical substance which indicates the acidic or basic nature of the solution by suitable color change. They may be natural or synthetic. Natural means what? Natural indicators are chemical substances which obtained from the natural resources. That is litmus, turmeric juice, China rose petals, red cabbage, grape juice, and beetroot juice are said to be natural indicators. In case of hibiscus flower indicator, some hibiscus flowers is soaked in warm water for about 5 to 10 minutes, form a solution. This solution can be used as an indicator In acidic solution, the color will be changed to deep pink or deep red. In basic solution, the color will be changed into green color. In case of beetroot juice, extract of beetroot also used as an indicator for identifying the acidic or basic nature of the solution. So litmus paper is a common indicator obtained from lichens. It is available in the form of solution or in the form of strips. By observing litmus solution on filter paper, it is either red or blue in color. Blue litmus paper turns red in acidic solution and red litmus turns blue in the basic solution. Turmeric indicators. By adding small amount of water to turmeric powder, a paste is prepared and is applied on a filter paper and dried. In acidic solution, turmeric indicator paper has no change. It remains yellow. In basic solution, the color changes from yellow to red. Next, move on to synthetic indicators. An indicator prepared from artificial substances is known as synthetic indicators. Phenolphthalein and methyl orange are the example for synthetic indicators. Phenolphthalein is a colorless compound. Its alcoholic form is used as an indicator. It is colorless in acidic solution but turns pink in basic solution. Methyl orange. Solid methyl orange is dissolved in hot water and its filtrate is used as an indicator. It turns red in acidic solution and yellow in basic solution. The following table gives the color changes of different indicators in acidic and basic medium. Color change in indicators. So 4 types we are going to see: blue litmus, red litmus, phenolphthalein and methyl orange. So blue litmus, it turns red in acidic solution and no change in color in basic solution. Red litmus, no change in color in acidic solution, turns blue color in basic solution. Then phenolphthalein turns colorless in acidic solution, pink in basic solution. The last one, methyl orange, turns red color in acidic solution and then yellow color in basic solution. This class we have discussed about acids and bases, their properties, uses, neutralization and then indicators. Phenolphthalein and methyl orange are artificial indicators, and then turmeric, hibiscus, beetroot, vegetables are natural indicators. Thank you, students.